My fourth Ocean Pavilion, and I have to say every experience has been unique. In any country we've been in, it's the first time we haven't had air conditioning or power, but we learn something new every time. Today we're very fortunate to welcome distinguished panelists to discuss marine carbon dioxide removal, in particular exploring ocean iron fertilization solutions. I think we all know in this room that urgent and at-scale reductions in carbon emissions are required to address the climate challenge. But we've reached a point over the past decade or so where active removal of carbon dioxide from the atmosphere is required, and I think that's why you're all here. The Ocean Pavilion is in part here to communicate the ocean's role in ocean-based climate solutions. Being the world's largest exchangeable reservoir of carbon, it has potentially the largest role to play in carbon dioxide removals. Here we're going to be exploring in this panel one particular class of marine carbon dioxide removal solutions known as iron fertilization or microplankton fertilization. And with this comes a need to really understand the basic science that underpins these solutions. And I think one of the foremost things that I would want to share with this group and a group outside of this is the central importance of basic science to inform both the viability and the scalability of the solutions, but also the safety and the ecosystem impacts of these interventions. So at the Woods Hole Oceanographic and at other oceanographics, we've actually established a position statement that you can find on our front page on our website that articulates the rules by which we engage on it ourselves. But here today we have a panel of experts that's going to be weighing in on this. And it's a great chance to introduce my friend and colleague, Dr. Margaret Leinen, former director of the Scripps Institution of Oceanography, one of our lead partners with the Ocean Pavilion. Margaret.
Thank you, Peter. And I'll try to be as loud as I can. And Marley, your job is to wave at any of us if you can't hear us, okay? Okay. So my interest in this area of climate intervention has really been in the codes of conduct or ethics of how you would do research on such a sensitive topic. And this issue goes back to 2010 when the Royal Society first published the Oxford Principles on climate intervention. And immediately afterward, I sponsored a workshop in Silomar, an international workshop on climate intervention that also included people from various stakeholders, whether those are social scientists, governance, the public, reporters, etc. This whole area of codes of conduct and ethics has revived in the last few years. And just a couple of years ago, Ken Buesseler, who's going to talk to you next, and Party Ramakrishna, who's in the back, and I published an article in Nature on established principles. And finally, many of you are members of the American Geophysical Union, and it has had a 2-year effort at developing codes of conduct for all climate intervention. And we will have a session on that. It's just devoted to climate intervention tomorrow, right here at the same time. So with that, I want to introduce our panel. First, we're going to hear from Dr. Ken Buesseler, who is a senior scientist at Woods Hole Oceanographic. He is a radiochemist, a marine radiochemist, and he's director of the Center for Marine and Environmental Radiochemistry. He studies the fate and distribution of radioactive elements in the ocean. And one of the reasons that this is so important is that one of those, thorium, can be used to trace material generated in the surface water as it moves through the water column into deep water. So it's a tracer of carbon sequestration. And he's been involved in multiple CDR efforts and leads a group called XOIS, which is looking at ocean iron solutions. Ken.
Thank you, Margaret. I feel like you're a little sweaty right now. You can't hear very well, but we'll see what we can do to keep you entertained here and tell you about the ocean that I love and I want to protect, but I also think we have to think more about helping the ocean and how the ocean can help us. So loosely, ocean solutions to climate that can involve putting ways to generate energy on the ocean, wind turbines, but they can also involve marine carbon dioxide removal. Now, you probably all know the ocean is getting warmer. It's taking up the heat that we're generating through climate change. 95% of that's in the ocean. You probably also know it's taking up about a third of our emissions like greenhouse gas carbon dioxide. So I kind of got brought into this around COVID to be a part of an academy and say, well, could we get more of that CO2 in the ocean? How could we do that responsibly? What would the R&D program be to do that? In the meantime, so this was 2020, a lot's been happening. There's a terrestrial CDR pavilion looking at things like direct air capture and freeze. That took off. And we're coming up behind with marine carbon dioxide removal. So why is the ocean so important for that? Really, that's where most of our carbon ends up. Do nothing. There's 50 times more carbon in the deep ocean than in the atmosphere. So no matter what we do, it's going into the ocean. Could we speed that up? Would that be a wise thing to do? How many ways are there to do it? That's the question that we kind of want to address. So I formed this group about ocean iron solutions. It's one of the older ideas about adding nutrients to the ocean to get more plants, more phytoplankton to grow. So I'm going to try something here, which is maybe you've all seen, pictures of marine plants, right? They're microscopic. They're very tiny, right? You need a microscope to see a marine plant. But in terms of photosynthesis, using oxygen, about half of the oxygen in this planet comes from these little guys. There's lots of them, they grow very fast. And so they're taking up the carbon dioxide when they grow, they're producing oxygen, and then the big thing is at some point they die, and it's usually pretty fast, days or weeks. Something eats this. This is really good food. If you're a zooplankton, you're a small zooplankton, you're a fish that eats on those. So there are lots of ways that these, we call them the phytoplankton heroes, help regulate that drawdown from the atmosphere, lower CO2 on the surface, and the deeper sequestration, the storage, that 50 times bigger reservoir. So we're basically, with the iron, and again, people don't commonly think of iron as a nutrient, but if you have a garden or something, and you might like nitrogen or phosphorus, hopefully not on the lawn, but on vegetables that you eat or something useful. Anyway, iron is just like that. It's a micronutrient, and unlike nitrogen and phosphorus, it takes very little iron to make a lot of those plants grow. So we've done this before. This will be the only other one of these I'll do. But we went out 20 years ago and we put about 1 ton of iron in the ocean. And we're going to see as well. And there was a horseshoe that you can see from a satellite. I think it's the first time oceanographers did an open experiment that you could see from space, right? You can look down on the ocean from the shuttle, you can take beautiful pictures. The green is the chlorophyll from that plant. We caused, essentially, this horseshoe of 100 kilometers scale. We caused the release and sinking of about 4,000 tons of carbon dioxide equivalent. We didn't get to how deep it got and how long it would stay there. So a lot of what we want to ask someone about CDR, what's the durability, not just how much, and what's the additionality? Could you say that we've actually caused this effect? Is that Mother Nature? No, that was people purposely doing that. so Exodus has never said we should go out and do this, but we're about 40 institutions, at least 60 people. We meet every month. You can go find us at Ocean Iron, come to our talks, read some of our literature. We think we know how to do the research. That's what academics have done, studying the ocean. And for that deep sinking part, we have new autonomous vehicles, cool tools to get at things we couldn't do 20 years ago. So a lot of new questions. It's an old idea in a way. 20, 30 years ago we could make these things happen. But is it the right thing to do now for a planet? So that's why I'm here. Thank you.
So next up we have Kalina Grabb. She is a postdoc at Dalhousie University, but she's also the research lead for Canada's Ocean Frontier Institute, which has a program called Converge CDR. And she's also the co-lead for work with ICES on the impact of CDR on fisheries. So she's looking at this from several points of view. And we're happy to have you with us, Kalina.
Thank you, Margaret. Thank you, Ken. Hello, everyone. Can you hear me? So yeah, my name is Kalina, as Margaret said, and I'm trained as a chemical oceanographer, but for the last 3 years I've been working on MCDR across the different techniques at the science policy interface. So I totally agree with everything that Ken's saying about, science must lead the way. We need a lot of research. And what I'm going to do here is kind of expand our vision in addition to science. What other considerations are out there, and give some examples based on the programs that I'm involved in. So the program that I've been the research lead for, we're just spinning up. It's called Converge CDR. It's run by Ocean Frontier Institute. We're located in Halifax, Canada, so just north of Boston on the Atlantic coast of Canada. And what we're doing is we're bringing together a interdisciplinary collaborative group to approach MCDR. So we have 4 pillars: science, engagement, economics, and policy. And we're recruiting postdocs right now to work on each of those pillars collaboratively on different projects. And so what we've done over the last several months across, some of it started as early as January this year, we have been what we were calling in the co-design phase. So we have this idea for the program, and we've been talking to a lot of MCDR practitioners, community members, First Nation members, as well as PIs, principal investigators, mainly led by Dalhousie, which is where we're located, in order to design what research are we actually going to ask across these pillars. And so we see this as a really important integral part of the program, because we want to lead research that is in response to what we're hearing the needs are in the community, and also to make sure that as it's kind of operating as an academic think tank, that we're answering the questions that are best suited for this type of entity. So we're a third party. We don't have any invested interest in the outcomes of MCDR. And so what we've heard from the community and what the PIs at Dalhousie have gotten really excited about are two main principles. One is the natural science part of the pillar are going to look at what the effects of MCDR beyond carbon removal. So we've heard a lot from the community. People are asking not only does this remove carbon or how much carbon is this, they're more asking how does this impact our fish? Can this clean up our water quality? And so there's questions beyond the carbon cycling that have to be recognized alongside the science of developing how we can remove carbon. And so these were referred to often as adverse impacts and co-benefits to look at. The other theme that we're hearing from the communities is the need for responsible and ethical engagement moving forward. And as the CDR community, we're recognizing how crucial this is. So as the science and technology is progressing, it appears that social license to operate may be one of the biggest barriers to MCDR. So this is something that really has to be thought of now and thought of alongside development of science and technology. And so Converge has a few First Nation PIs that are leading a few projects, and They are co-designing with the community in order to listen to the community, run workshops, get feedback, and bring community leaders into the projects in order to align the priorities of the community. They're asking with the science that's being done. And this also goes hand in hand with the translation to policy as well. Thinking about policy regulatory frameworks, which is a big topic right now in CDR. What are the regulatory options in the future? These also need to be thought of alongside what the communities are looking for, have participatory processes to include community input, as well as what we're thinking about with the co-benefit side. There's a lot of environmental impact assessment frameworks coming online right now, and this process of enforcing environmental impact assessments or encouraging projects to use them can go hand in hand with the development of regulatory processes and the requirements for permitting in order to make sure that just as Ken was saying, that these are safe techniques that are being developed. So the other piece that I'll mention briefly, and happy to dive into more later, is the work through ICES, which is the International Council of Exploration of the Seas. It's a consortium across the Atlantic, so North American countries as well as European countries. I've been co-leading this group with several other colleagues from DFO Canada as well as PML and UK. It was started by NOAA last year, and so we've carried on this effort in order to engage fishers and fishery communities as well as aquaculture farmers in the discussion about NCDR. So we've had several workshops so far, and we're forming a working group in order to continue this. Right now we're working on a lot of frameworks to look at what is the overlap between NCDR and fisheries, what can NCDR learn from fisheries because they've been around, they've been managing many decisions on the ocean for a long period of time, including in the high seas, as well as how can we work together to make sure that any negative consequences are minimized and any opportunities across economics, science, engagement, make sure that all of those opportunities are maximized. So yeah, excited to continue the discussion.
And that was a perfect lead-in to our next speaker, who's Dr. Shaun Fitzgerald. He is the director of the Center for Climate Repair in Cambridge, England. And he works at the interface of academic research, business, government policy, and public engagement. And before he was in this position, he was with the Royal Institute. He was the director of the Royal Institution. And he was overseeing their programs of public engagement in science and engineering. Shaun.
Great. Okay. I'm hoping you can hear me at the back. So I'm Shaun Fitzgerald, and I'm part of a program that is a European Union funded research project called CO2 CDR. And I would encourage you to, if you're going to write anything down today, just write down CO2, but it's SEA02 CDR. And it's one of 3 projects that were funded by the Horizon Europe scheme, each one of which is about 7 million euros. So I remember 4 years ago at COP in Glasgow, and there was a call for proposals. And I was interested in this idea of getting together a consortium on looking at ocean-based, marine-based carbon dioxide removal. And this is one of the great things about COP, is I went for dinner one evening, and I dragged this guy for dinner. We were about 30 or 40 of us there. His name is Chris Pierce, and he works for the National Oceanographic Centre in Southampton. And I realised that Chris was also interested in this call and had been chatting to some people. And I said, well, Chris, we should hitch our wagons together, and I think, Chris, you should lead it, because he's an oceanographer and I'm not. So Chris kindly took on that burden of then leading a consortium. So there are a bunch of universities, entities, all based in Europe, because that's primarily one of the conditions of funder. So I'm loving when I hear other communities being involved and funded. But so we've got universities from Warsaw, Kiel, Madrid, Rome, Cambridge, Heriot-Watt, and Southampton, etc. And we are looking at a project which is trying to get a better handle on the whole space of ocean-based carbon dioxide removal. So the way this is configured, and I like doing things in threes. So the first thing is more science-based. So there are two legs to the science-based question. And the first is just getting a better scientific understanding of what on earth goes on if you attempt to do carbon dioxide removal from the oceans. And by the way, one of the good reasons to ask the oceans, and the quote Ken mentioned about is there a role, is that if you want something doing, who do you ask? And generally you ask a busy person because they know actually how to go and do stuff. Well, the ocean has been very kind. All right, it's taken up a third, a half of emissions today, but it's got a vast resource. So this is the reason why we're pursuing this line of inquiry. So the scientific questions are things like, what about the ultimate fate of carbon dioxide that's been taken up by the oceans? Ken mentioned this. How do we go and get an understanding of, does it come back into the atmosphere in fairly short order, or does it go into the deeper ocean and then either gets to the seabed or actually to return on a time scale of, say, hundreds of years? So this whole idea about additionality, monitoring, reporting, verification, it's a scientific question. That then cascades to another line of really scientific inquiry in that same bucket, which are things like life cycle analysis, techno-economics. So we've got a team in Heriot-Watt that's looking at this. And it's really, really important by trying to understand and get a better handle on what would the costs of a system be. In other words, if you're going to ever look at carbon markets for this sort of stuff, you need to have a really good understanding of the overall economic situation. So that's bucket one. Bucket two, there are three bits within this. The first is getting an understanding of public perceptions. Ken said, is it a good thing? Well, what do people think about the ocean being used, targeted as a way of perhaps helping us? And actually, are there co-benefits? Do we get increased fish stocks? Actually, should we make the oceans a bit greener? So when we see the picture of a lovely blue ocean and we think that looks beautiful, is it actually healthy? Is the right question we should be looking at. What should it be like? So public perceptions. And then of course we've already referred to things like policy, governance frameworks. So actually, how do you go and approach this from a governance point of view? And governance is really important. Governance is not there to stop you doing things. School governors do not run a school to stop the school from functioning. Governance is about trying to prevent you from doing the wrong things, but enabling the right things. So there's a whole piece on governance, and then there are also a role for businesses. What are the right commercial frameworks in order for commercial entities to then participate in this space in due course, whenever that is. And then the third piece is trying to bring this all together. So that means feeding into integrated assessment models, which we have a team doing that as well, and then liaising with some of the other partners that I mentioned as part of the European Union project. There are 3 projects. One of those is very heavy on integrated assessment models. So actually not just having our project, but our project interfacing with other projects as well. And then the very last bit, bucket 3, is trying to bring that together and synthesize it. So we don't care passionately about a particular approach, and we try to be as cold and as objective as we are, but we're passionate about the work. So that's different from being passionate about we want this to work. We want to find out whether, for example, ocean iron fertilization might work. And Ken's in the same boat. We want to put a lot of effort into trying to understand what would it take and is it the right thing, might it work? But we are also keeping our eyes open as to other forms of ocean-based carbon dioxide removal. But at the Centre for Climate Repair, we're also looking at different forms of intervention. So hence we've got an event subsequently with Ken looking at just carbon dioxide removal more generally, looking at terrestrial forms as well. So just making sure that we are keeping our heads above the parapet and knowing that there is a role potentially for ocean-based carbon dioxide removal in the whole armoury of our fight against climate change. And I'll leave it like that, Margaret. Thank you.
So I'm going to ask them a couple questions and then throw it open to you for questions. And if you don't have any, I am bored. So the first question is, Ken wants to do an experiment You want to make sure that we have social license to do it. Shaun says we have to have governance. So there haven't been many experiments lately. If I wanted to do one, whose permission do I have to get? Who regulates this if I'm doing it out in the middle of the ocean beyond national jurisdiction? Anybody?
I'll start about that. So one thing you probably know is that 2/3 of this planet is covered by the ocean. That's what we basically. The high seas is really where I'm more focused on, outside of the exclusive economic zone. That's 2/3 of that. About half of the surface of the planet is high seas, no jurisdiction. So when people ask me that question about jurisdiction, now we're talking about international, the London Dumping Convention back in the 70s, London protocols that have been adapting what people put in the ocean, what can you place in the ocean, how is that regulated? These are, I guess, as a non-political person, imperfect arrangements. Not everybody follows them, but I think what's really been nice about the idea of iron in the open ocean, and I should have said iron mostly comes from dust and land, so that's a place that is not growing much iron. So my group is really focused on these high seas and who controls it. Well, under those protocols, they do have an assessment process that each country is responsible for. And 3 key words in that assessment: they allow you to go take a ship, do an emplacement with iron, look for results if the benefits outweigh the risks, but you have to be doing legitimate scientific research. So that in a way, they've outlawed commercialization. It doesn't always stop the rogue pirates, the bad actors, but at least there's a responsible way under these international protocols, and at least in the United States, that involves the US EPA. You write the permit, you get public comment. It takes at least 12 months. We didn't do this 20 years ago. We just went out, scientists, and put iron off the back of a ship. But that's come a long way, and I think it's good we have these types of agreements for legitimate scientific research anyway. It doesn't solve everything, but the research path, I think there's a governance framework for that.
I'll talk about social license. So, Kalina, you said we had to have social license. So what kind of engagement is necessary in order to get social license?
Yeah, so I'll just say again, I'm approaching this from oceanography perspective, and I've worked a lot with social scientists. And so one thing that we like to talk about a lot is that engagement does not necessarily mean that social license will be there. But you have to first do engagement, meaningful and purposeful engagement, in order to have a chance at building social license. And so it's up to the communities on what they think of these, of different actions, such as NCDR. And that's why it's so important that as NCDR community, we use all of our resources collectively in order to build that trust and work slowly at first so that we can go fast later. And so, for example, one thing that we recognize as an independent academic think tank is that we actually have the ability to go out and slowly work to build trust in the communities, which is not necessarily doable from, per se, companies that are trying to get carbon credits. So there's different actors that can work together in order to build the steps needed to work towards social license. And the other thing I want to mention is, while we're thinking about the high seas, some people might say, well, there's no community there. Like, why do we have to engage anyone? And there's a lot of communities that are still involved in these processes to do a deployment at sea. So even thinking about life cycle analysis, where is the feedstock coming from? Where are the ships coming from? Where are the crew coming from? What's the downstream effects of a deployment that may affect an ecosystem somewhere else where people are or that they rely on? What about the fisheries that are in the high seas? So there's still a lot of communities to consider in this, and as we've seen in the past, it's really important that we get this, that we start the engagement, we get it right sooner than later, so that we set off on the right foot before it's too late to change the public's mind.
Shaun, Pan referred to the International Maritime Organization, IMO, and their ability to give permission. That's a science-oriented permission. You know, you're doing the thing right. What about governance? That's one form of governance, but are there other groups that have to weigh in on whether or not you do an experiment? Or should there be?
So the question is, are there other groups other than, for example, the IMO that you need to liaise with? And if you want to do this kind of work, so doing outdoor experiments on, let's say, putting some nutrients into the ocean, the fact is that you're going to attract quite a lot of attention. So in fact, you need to think, in my view, beyond that which is actually legally required, because there's engagement, but actually making sure that you have the support and involvement and inclusion of, let's say, some of the stakeholders that Lena referred to as part of your community of pursuing science. And that's A, because it's the right thing to do, but B, it actually just makes sure that when you have, and it's very likely that you'll get people sort of concerned about your activities. I mean, for example, if you're working on carbon dioxide removal, even though it's not as common now, but it has been historically viewed as a mitigation deterrent. So if you're looking at carbon dioxide removal, does that mean that we're weakening our resolve to get off fossil fuels? Today, I think that's not a big argument, but certainly 15 years ago it was. By the way, I don't think it's a big argument today, otherwise we wouldn't be talking about the term net zero in law. So the governments have actually signed up to the net bit of net zero. So I think it's really important that you engage with other communities. I also think there is a mindset, which is also really important. And that is this. We have treated the oceans rather badly, I think you'll know, plastics and things like this. But if we look at the industries which are taking things from the ocean, what are we doing in return? So do we just take, or do we tend to the ocean? We moved away from being a hunter-gatherer on land many, many years ago. And actually with 8 billion people on the planet, we have to work really hard at tending to our fields to make sure that they remain productive. We need to care for them. So I think there is a mindset now, a relationship with the oceans. And right now we are still very much in the take. And actually scientifically, I'm posing the question, is that the right thing to be doing? Or should we be doing something more than that, which can be, for example, creating habitats, which could be growing, for example, giant kelp, and perhaps not just restoring where it previously used to grow, but in new places to try and enhance ecosystems. These are really big questions, but we need to be thinking in a more positive way about caring for our oceans.
So I got to ask some questions. I'm going to throw it over to the audience now for some of your questions. I have some others, so if there aren't any, I have some questions here. But your questions. Please stand up and yell. Could you identify yourself too?
My name's Kieran Lorenzen. We have a really suggestion besides doing experiments. What is the geographic scale with sea layer into the ocean? You talk about less coastline, but then maybe miles or
Well, there's a range of scales.
Can you repeat the question?
The question was about the range of scale we would need to go if we're going to start testing some of these ideas that we have, right? They're often specific because on some processes we really don't have much data at all. And so you start in the lab and on the bench top and you grow animals and you add chemicals to change alkalinity and see how is that harmful or not, right? So there, everything from a bench top to large deployments. I showed on my laptop when I walked over a horseshoe shape that was about 100 kilometers across. That is actually a pretty small perturbation in the ocean. When we think of iron as a source of minerals in the ocean, we think of volcanic eruptions. The Aleutian Islands of Alaska in 2010, Kashitoshi erupted and lit up the entire North Pacific from Alaska to the Pacific Northwest. Lit up meaning it turned red, green with chlorophyll. So we're not talking about that scale, but we are talking about things that might be 10, 100 square kilometers at the start, but then a few thousand by the time they grow. So it's interesting, a lot of the language, they talk about small scale. What does that mean? For me, that's look at Mother Nature. Let's not exceed what we think is reversible and not going to permanently change, say, ecosystems or habitats or chemistry. So we want to keep below that scale. But we've got to get bigger than just a few kilometers for a week or two. Back 20 years ago, we left the scene after 30 days. Now we have autonomous vehicles, so it's also not scale and size, but duration. So we're thinking of 6 months, 12-month duration experiments to follow what might be a 1 or 2 month perturbation of phytoplankton. There are Canadian sites, coastal sites, that maybe others can address, but they're much more focused and narrow where they're releasing chemicals in the ocean, and those are starting now smaller scale. And so range of question answers, but it's not space, it's time as well. How long should you be watching that perturbation? That's important to ask too. And I guess I'll just have to say too, it's not just carbon, I think people said that. It's monitoring, reporting, verification, MRV of carbon is important. That's what markets are looking for, that's what countries, the CO2. But the environmental, ecological NRV, the monitoring of the ecology and the chemical changes are just as important and probably would lead to choices being made not to do something before the carbon efficiencies come in. So MRV and EMRV, we need two types of monitoring.
I can just add on briefly about I would say in Canada there's some deployments happening right now. Right now we're still at the point with UCR where what we're talking about is enabling research. And so these are small scale, and the research is really what's needed in order to understand if is it removing carbon and what are the net benefits or impacts to the environment, as you mentioned. And so a lot of the research that's happening is projecting about scalability. They'll still add a larger scale what would be the impacts, but we are barely beginning into the ocean right now to do research. So at Hui, which I was at Hui previously, there was just a field trial, which was one of the first field trials to be permitted in the US. And the analogy is like putting a teaspoon of sodium hydroxide into a bathtub. So that's like about the scale that we're at right now on an ocean basin to look at. It's very small, but it allows us to, as scientists, to investigate what the changes are. And the other thing to think about scale-wise when we're talking about social license in communities is MCDR techniques are very specific to different regions. There's different regions that different techniques might be more favorable than others. And with that regionality, the communities are very different. They're going to have different marine economics. They're going to have different histories of different sectors that have engaged in the past or different pressures that they felt. And so while we think about global frameworks and recommendations and things like that, it's really important to take that and apply it to a specific region where a project might be going on in order to start from the ground up from a local scale and build from there.
Hi, I have a question. My name is Anya. I'm a student at Scripps Institution of Oceanography, and my question is coming from a zooplankton ecology perspective, so it might be a little silly, but I'm hoping, I don't know, maybe you would have some insights on this. So when I think of marine CDR, the efficacy of that comes from the carbon actually being exported, ultimately making it out of the photic zone. And as we move forward with the climate changing, we're seeing increases of warmer temperatures, which recent research is showing favors gelatinous zooplankton such as pyrozoans, which are less efficient exporters of carbon than, say, other zooplankton that have these dense fecal pellets that sink out. And so I was just wondering if that's something that is considered with marine carbon dioxide removal, is how these co-occurring synergistic climate changes might affect MCDR's effectiveness, basically. Does that make sense?
I can speak to that.
Yeah.
Yeah, so you're actually right on track to what some of the cutting edge questions are. So with the ICES work that I've been doing with fisheries, we've actually built this database of papers that have looked at biological and ecological effects from MCDR across the main 6 MCDR techniques. And then we've categorized it by what different organisms are they talking about. In zooplankton, for example, actually anything beyond phytoplankton, there's very few studies that have been done out there. So a lot of studies have been done on iron fertilization and ocean alkalinity enhancement, mainly on phytoplankton. And then as you go up the food web, there's very little literature out there currently. So one thing we can do is lean on other fields similar that have done research similarly. So like ocean acidification, we're still thinking about carbon perturbations in the ocean. So what can we learn from all the experiments that have happened there? And that's where a lot of MCDR scientists are turning right now, in addition to starting to perform experiments in order to understand this. So some of the very early field projects are recognizing now that in order to get their permits, they have to look at, both as a responsible way and as a regulatory way, they have to look at what would be the impacts for the local species in that environment. And so there's like less than 20 studies on this about phytoplankton, or about zooplankton. And some are starting to look at larvae, understanding that there's, early life stages are really important to understand the impacts. So it's growing. The very early studies on zooplankton have talked about there are some shifts in community structure. There's also some shifts in the makeup of the carbon to nitrogen ratio within the biomass of phytoplankton that then impact the zooplankton, which then go up the food web. It can impact the amount of nutrients that are going into fish and things like that. So it's a really interesting space. People are starting to think about it and recognizing how important it is. But thank you.
So, it's a great question, and I think it just points to the need for, I'm going to come back to the bit that I talked about right at the very beginning, more sophisticated modelling, because we're not going to get full understanding just by monitoring small things on their own. So it does mean developing models that can combine basically evolution in an ecosystem. So I don't mean genetic evolution, I just mean in terms of changes from a biological point of view, and integrating that with models that capture the physical parameters, whether it's temperature, conductivity, and the nutrients within this. So we need to build that sophistication into the models, so that when we do look at changes in temperature and the cascading effects of changes in biological life forms that are going to be predominant in different areas, that then all gets captured in the relevant models, so that we can then make the appropriate deductions about what the potential impact might be for carbon sequestration for a given approach, especially for those the impact on the biological activity. You're completely right.
Can you move forward?
So in 2012, this road actor across the Georgia dumped a lot of iron out in Canada with the hope of doing sort of like a philanthropy carbon dioxide removal project, but it wasn't really regulated, it wasn't scientifically monitored. And the question for you is, do you think this has really harmed the public perception of iron fertilization? And if so, how will we correct it?
Okay.
That's absolutely
Want to answer?
Okay. So the question was, in 2012, there was a rogue or a pirate geoengineer who went off Haida Gwaii. He actually convinced a local native Haida group to borrow money so he could increase their salmon return. He wasn't even promising CDR at that point because he couldn't show carbon removal, and said, I'm going to give you a lot of salmon. That set us back so far, because what he was able to do is create this event in the ocean that we could see again with satellites. We looked, and yes, indeed, where he took the fishing boat, things turned green. But he had no idea what the ecological responses were. None of those data were shared with the academic community. The public, by not asking the question, all of the press was about this illegal activity. And when the salmon were looked at, this is classic. To this day, they will show up at a conference and they'll show you how many salmon came back 1 year after they added iron. Wasn't this great for this tighter community? Salmon return was great on the Fraser River. Well, talk to any fisheries biologist, salmon fisheries in particular, it takes 2 years for those juveniles to go out, feed, maybe get a little fatter and come back because of this. And it wouldn't just be one species. Salmon are affected by what's happening on land these days, the quality of those rivers, shoreline fishing, and what happened offshore. So really, this type of behavior set us back, and what you do to get around that, you just have to lead by example, I guess. That's why we've been really careful with our group to kind of be bottom-up, academic, social science, governance, code of conduct. The very first thing we did, we said we're doing this for the benefit of humans and the environment. If we can't demonstrate that, we shouldn't be doing this. If we can't do this in an open and transparent way, it should not be allowed. I would think if we had these codes of conduct, Margaret mentioned that when she introduced this, if we can get the people who provide the funding, people who do the work, the commercial companies who want to invest in this, there might be markets down the future. If we can all come up with a common code, or at least tell the world why, what we're doing this, who's funding that, I think we'll go a long way to putting those stories back in the past. But they're still out there. There could be a headline tomorrow by one of these rogue geoengineers, but that's something to be avoided, and make sure we have the distinction between that activity and something else. But that's very hard to do. So we tried. 20 years later, we're still trying to get out of that setback. Good point.
So what I'm going to do is just put a tiny bit of colour in a different way on that to follow up from Ken. I mean, tomorrow morning in the GAUC Pavilion, we will be talking about the role of private companies in actually this field of carbon dioxide removal. And what your question has done is it's really just highlighted one of the problems that can be manifest by bringing in private capital into this field. And the real questions are about not should they be barred from this field, but how and when, and what role should they play? So it's not clear. So should they also be involved in helping think through what does governance look like? You might think that's a terrible idea, but in my previous work when I was in the construction industry, when we were looking at changes in building regulation, you need to bring in the companies to help educate you about the way an industry might work, so that the regulations that are then developed are then fit for purpose. So it's not that they have zero role, it's just that they need to be carefully curated. I think in this case, it probably was, an example of where industry, private capital was able to act probably too early. The ultimate intent, of bringing, private money to bring for good in this space, I feel that's where we need to be thinking, but we've got to go and help navigate and curate this. But clearly we've got to address the first question is it a field that's worth carbon dioxide removal at all? But if it is, I think there is a role for private capital. But we can have more discussion about that tomorrow, because that particular example, it was pretty challenging for the field.
My name is Dimitri Gutierrez, I come from Peru. I don't know if I missed something, but I want to know if there is an estimate of which is the best estimate we have of this current level of understanding of the amount of carbon dioxide you can achieve with iron fertilization related to the gap we need to close in 2021.
That's one for you to start with, Ken.
So the question was about the scale, and I think I want to address more than just iron fertilization. That's just marine CDR, carbon dioxide removal. We're looking at emissions that are 40 billion tons of CO2 per year. We got to get that down. 5, 10, some small number. We know how to do that. We need reductions on the scale of 5 to 10 billion tons, gigatons per year of carbon dioxide. 5 to 10. Every one of these marine techniques, ocean iron, might get you 1, 2, depends, but you can scale. You can't get all of it with any one. So my suggestion is if someone says, I have the one solution, we walk away. We're thinking we need iron, we need seaweed, we need alkalinity. We'll probably have some land-based ones that are worth doing too. There's electrical. If we had fossil fuel-free energy, we could take with the electrochemical technique CO2 out of the ocean and bury that as well. We don't have, in my opinion, fossil fuel-free energy to do that. It's much better to remove it from the source than to take it out of the atmosphere at the end.
Compare that with the full potential of some of the other carbon dioxide removal approaches. Things like iron fertilization. You're getting to numbers that are probably bigger than other approaches. They're just not big enough on their own, but they become really, really interesting lines of inquiry, and that's why we care passionately about the field and why Ken, and I support Ken in this, this is a particular approach that is really worthy of investigation.
Also,